Gazing up on a dark, moonless night, we look in awe at millions of bright stars suspended in dark space. We wonder at the vastness of the universe. It looks limitless. But the universe is not infinite, and the stars and galaxies are not motionless. Whichever way you look, they are accelerating away from us. The whole universe is expanding, and space is getting bigger. The galaxies are moving away from each other like currents in a rising lake. It means that if we reverse the movement, everything would focus down into a tiny point. As the galaxies retrace their steps, they move closer. 13.7 billion years ago, all the matter in the universe was crushed into an infinitely small point, the sea in Earth. It contained all the matter and all the energy in the universe. And then, before the Big Bang, there was nothing. No space, no time, no matter. Just nothing. At the Big Bang, time began. And for a brief instant, in fact 10 million trillionths of a second, even the four fundamental forces of the universe, gravity, the strong and weak forces, and the electromagnetic force were the same. As the universe expanded and cooled, gravity separated from other forces first. Then, strong force separated. The tiny sub-atom-sized universe suddenly expanded 1,000 million times in just a tenth of a second. Almost instantaneously, it became 10 meters in diameter. This amazing growth is called inflation, and after it happened, the universe was changed forever. Inflation made the universe small. It is even throughout, the same temperature and density everywhere. Einstein discovered that energy and matter are interchangeable. About a nanosecond after inflation, energy turned into matter and antimatter, but there was slightly more matter than antimatter, and as the two opposites annihilated each other, a small proportion of matter was left over to become today's universe. When the temperature cooled to 10 quadrillion degrees, quarks, muons, electrons, and neutrinos appeared. From about 1 microsecond to 1 second after the Big Bang, the universe cooled enough that quarks began to stick together to form protons and neutrons. The familiar building blocks of the matter we know today. When the universe was just 10 seconds old, photons dominated the universe and interacted with particles. After a minute, some protons and neutrons associated to form the nuclei of the simplest elements, helium and lithium. Independent atoms were formed when primitive positively charged nuclei collected negatively charged electrons to balance their protons over the next 300,000 years. 380,000 years after the Big Bang, photons did not associate with any other particles, and as a result, wandered the universe forever. They became the cosmic microwave background radiation we can observe in every direction in the universe today. With all the building blocks in place, giant structures could grow. Matter clumped together under its own gravity, forming the first stars within proto-galaxies. The proto-galaxies became galaxies, and the galaxies associated into clusters and superclusters. The universe is dynamic and constantly changing. Nuclear reactions in the stars make heavy elements. Giant stars explode as supernovae violently throwing material out into space, where it floats in the void for billions of years. It is eventually picked up and recycled in future generations of stars and planets, just like our Sun and Earth. It is literally true to say that we are made of the stars.